Good evening to one and all present here. I'm Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. Radhalakshmi, SNS Rajalakshmi College of Arts and Science. Today we are discuss about the subject agent for computing. Today we are discuss about the edge computing purpose and definition. Uh, this presentation is the most probably the fundamental of computing. That is a more concept. It is the modern digital landscape. We are using and enhancing the data processing, security, and real-time operations. There are three process and discover and how to enhance the edge computing from data processing and security and real-time operations. First of all, we have discussed about data processing. The data processing is nothing but we can data and send and receiving time, they enhance the processing time, and also it is reduce the data processing time, and security it most important of this send and receive time. So enhance the security level. How to secure the data? It will be transferred to one machine to another machine. Easily we can enhance the security level. And real time operation, which means the real time operation is we are using to real time application. The time the real time operation is very essential. So this fundamental of the edge computing, the purpose is very important and crucial role in modern digital landscape. Next, we will discuss about purpose of edge computing in today's digital world. First, we will discuss about what is the data growth. The data growth is very important. Some of the devices we have needed. What is the device? Is a communication from IoT devices. So this is managing the information for all the streams. Easily we can managing the purpose of the IoT devices. Next, the real-time decisions. The real-time decision is nothing but some of the critical situations when application is crucial time. It is a real-time handling for all the applications. That means real-time decision. And next we discuss about what is overcoming the limitations. The limitations is bandwidth and latency limits is very important. So they are common of the cloud solutions. So the bandwidth and latency, it is reduced the time, common for all the cloud operations. So this is the overcoming of limitations. Next one is what is the enhance the compliance and enhance the data sovereignty and also meets the compliance requirements. So some requirements need for the enhance the customer complaints, how to requirement from the customer. Easy we can rectify the complaints. So how to make the enhancer from the complaints. It is what is the edge computing and some simplified the definition. There are three processing. The first one is what is a decentralized processing and framework definition and future projection. The decentralized processing, which means the process the data in near its source. The edge computing and computing is the near source how to access from the client. This is different from centralized the cloud. The cloud is centralized, but edge computing is decentralized. The decentralized, which means easily we can data receive from the certain limit. So particular near in the source which data we want, easily we can processing for all those resources. So decentralized processing is the different from centralized cloud. Next one is framework definition. The framework definition is nothing but the edge computing is a decentralized computing. It uses of the local resources because of lot of resources we have need in cloud. Because of that is a centralized process, but decentralized process it uses of local resources. Easily we can include the easy we can compute and storage and networking, processing time, all the data so resources is available from local sources. So it is a framework definition. And future projection is IDC predicts the enterprise of data will process on edge by 2025. Because of easily we can all the data locally we can access for data from all the uh, client. So this is one of the best future projection from predicts of 80 percentage of 2025. Okay, next, how edge computing brings the data closer to the source. There are four process. First one is local processing. Next one is local analysis and reduced transmission and traffic reduction. Local processing it is occurs of sensor level. We can processing of sensor level. It will also happens to the gateway devices. That is the meaning of the local processing. And the local analysis is nothing but the filter by all the data in locally, and if, easy we can reduction from unnecessary transmission. Because of lot of data we can reserve the time. The locally we can find out for all the data information and filter the all the data information. Easily we can unwanted data's transmission time we can save for this local analysis. And reduced transmission is nothing but the only essential data it should be sent to the central cloud, but optimize the network usage. Because of cloud data it should be the centralized data processing. That time we can send the data is we can send the longly. So the decentralized means locally we can finding for all the data. Easily we can optimize the network usage. That is the meaning of reduced transmission. And traffic reduction means it will be a the centralized data in cloud data we can access from it is all the data information is not only reduce the transmission. So the time the traffic direction is help of the edge computing we have using from the 80 percentage. So the traffic reduction is one of the best advantages of the edge computing. So some of the data closer to the source, easily we can data transmission and receiving time we can save. So the centralized data we can we cannot send the data, we cannot receive the data in short time because of a lot of data in remotely we can access from the cloud. So the time traffic detection is too long. So the traffic detection is the edge computing we have using the source traffic detection, and also the can help to the 80 percentage of data it will be traffic reduction. Next one is edge computing and bridging the gap between devices and data centers. They are first one is the intermediate layer. The intermediate layer is we have created between the device and the cloud. So the intermediate layer we can access to long transmission to the cloud, but the edge computing between the gap between the very local processing into the source, easily we can data we can the transmission time we can save the so intermediate layer is the local processing is in edge computing. And second one is fog computing is often the completes the edge, it supported for the wider local networks. And seamless data flow is across a distributed environment, easily we can distribute it from all the environment. So that is the meaning of data flow. And hybrid cloud is nothing but one of the architecture of easily we can performance, the combination of edge and fog and cloud, we can move all the data transmission time, the performance is ensure the automates the performance. So it is a mainly support from the hybrid cloud architecture. Next one is real-time processing, a core purpose of the edge computing. The edge computing is it is enabled through immediate analysis, and it allows the rapid response to events. The system is we example the self-driving the cars, they provide the milliseconds of reaction times. Easily we can safety and efficiency of various applications, and they are immediate analysis and response and critical for autonomous system, and millisecond level reaction times, and 100 millisecond latency can mean the 2.8 m stopping the distance at 60 mph mile per hour. Easily we can moving for all the time because of we are using two sensor, easily we can safety and efficiency from various applications. Next one is the reducing latency through edge computing solution. They are 5 to 10 millisecond. The edge achieves the extremely low latency because of the application responsiveness is very improved. And cloud is 50 to 100 milliseconds because of it is a centralized, we can called as significantly higher edge provides a crucial speed advantages, but edge computing is minimize the data travel distance but significantly improve the application responsiveness. But it is essential for a sensitive application and remote this include remote surgery and live gaming and smart grids. Easily we can through easily we can reducing latency from the edge computing. Next one is enhancing data security and privacy at the edge. The benefit of the edge computing is local processing and also reduce the attack surface and compliance facilitation and breach protection. The local processing is the data is processed stored locally, and reduced attack surfaces limiting of transit reduce attack the vulnerability, and complaints facilitation is in case against of GDPR is one of the local data regulations, and branch breach protection is vulnerability of large scale data branches, centralized data risk, and easily we can mitigate it. And benefits of edge computing. Edge computing offer many advantages. They improve the operation efficiency and reliability is significantly, and lowers operating cost through the reduced bandwidth usage and enhance user experience via faster responses, also boosting of innovation capabilities. There's a conclusion of future in is the edge, the fundamental for growth, and the growth is it is a drives the AI growth we can implement from the 2025 onwards, and drives automation is intelligence automation. This is spans across all the industries and enabled capabilities. It is a new capabilities. This support from the crucial real time applications and essential for the future, It is the essence of connected by security responsible of digital world. Thank you.